Hi guys, welcome back to Maison African Motives, still on mathematics grade 12. As a continuation, we are still working on revisions and questions so that we practice as much questions as possible. So we're going to focus on number patterns, working from the question paper, which was written in September 2020, Eastern Cape. So yeah, there are so nice questions that I saw here that we can actually work from and practice from there as much as we can. All right. We are given the first question 2 that we are going to focus on, which is having a quadratic number pattern, and we also have an arithmetic sequence here. So it's actually a nice question to work with and actually having a total of 18 marks. So it was a good question. All right. So without wasting much time, we are going to quickly rush through the questions we are given on 2.1. Given the quadratic pattern, this is a quadratic pattern that we have. Write down the next two terms of the pattern. So these are quadratic patterns. So I'm just going to explain one or two from this quadratic pattern that we had. So take note, this is 2.1. Okay, where is my marker? All right, so it's 2.11. So we're actually given 86 followed by 119, followed by 150. Followed by 179. All right, so these are actually the numbers that we had. All right, up to 179. So we need the next two terms. All right, so when dealing with a quadratic sequence, what you need is to find first the differences. Remember, we must have the first difference, then the second difference. So here we are going to find the difference between these terms. All right. Okay, so what you do is that you're subtracting. This is your T1, this is your T2, this is your T3, this is your T4. So to find this term here is T2 minus T1. Okay, so that's what you're going to do. So that's 190 minus 80, and of which you can use your calculator to do that. All right, 119 minus 86, which is something like 33. So here we are going to obtain 33. We do the same 150 as T3 minus T2. All right, which is 150 minus 119. 150 minus 119, that's 31. So this is going to be 31. 179 minus 150. All right, so it's going to be 179 minus 150, which is going to be 29. So this is the first differences. These are the first differences that we have. Then we move on to the second one. All right, it's going to help us a lot if we just have this. Since it's good for you to have this, even if you can have a shortcut, but it's good for you to have this since you're going to use it also later on. So it's actually good for you to have this because you use it later on, you will definitely have to use this one. So that's our second difference, 31 minus 33, which is a negative 2. That one we can clearly see. This is negative 2. 29 minus 31, that's negative 2. All right, so remember we are supposed to have the next two terms to find the next two terms. So what you're going to do, you're going to take advantage to know that here the second difference is the same throughout. So we are going to have another, we are going to have a second difference. Let me use another marker here. We are going to have a second difference again of negative 2 here. So what happens is that along these ones, you add 33 plus these 2, negative 2, it gives us 31. 31 plus negative 2, it gives us 29. So to find the number that you're going to have here is going to be 29 plus negative 2, which is something like 27. So this will be 27. Remember, there are two terms that you need. So we are going to have another one again. From 27, we have another, still having our negative 2 here. So we are going to add again, just like what we saw on this one. So this will be 27 plus negative 2. You add here, which is 25. All right. So that's it. The same thing that you're going to do back here on 179 to find the next term here. You add. This is what is happening. 150 plus 29, we get 179. Okay, 179 plus 27, we get the term that is corresponding here. So it now needs a calculator here. 179 plus 27, which is 206. So this will be 206. So we are going to have 206 here. We do the same on 206 to this term of 25. We add to 25, we obtain the term that follows here. So it's 206 plus 25. Okay, that's 206 plus 25, which is 231. So this term is 231. Okay, so these are the terms that we're being asked to have: 206 and 231. Okay, those are the two terms that you're going to have there. All right, let's check the other part. 2.12, determine Tn, the general term of the pattern in the form. We are given the format. Sometimes they might not even give you the format. As long as you're dealing with a quadratic, you must know the format, guys. Okay, let's try by all means to know this format. Okay, so we need the general term of the quadratic sequence that you are given. So remember, ring that to, okay, this is 2.12. Okay, we've got our Tn being equivalent to an squared plus bn plus c. All right, so remember that the second difference is equivalent to 2a. So 2a is equivalent to -2. So you can divide by 2 both sides to obtain the value of a, which is -1. All right, then we move on to the first term here, or the first term of the first difference, which is 33 here. It is equivalent to 3a plus b. So it is equivalent to 33. So that's what we are going to take here. So having the value of a, because already our a is -1, this will be 3 by -1, which is -3. So this will be -3 plus b is equal to 33. So definitely I have to transpose 33, -3, sorry, to the other side. It's going to be a +3. So b is going to be 36. All right. Then the first term here, which is our T1, is equivalent to a plus b plus c. So a plus b plus c is equivalent to 86. All right, so that's 86. So now let's substitute the values that we are given. We have got the value of a, which is -1 here, the value of b, which is 36. So we can actually add -1 plus 36, what we have here, -1 plus 36, that is 35. So this is going to be 35 plus c is equal to 86. So I have to transpose 35 to the other side of the equation, which will be -35. All right, so c is equal to 86 minus 35. So that's 86 minus the answer that we got, which is 51. All right, so that's the value of c. So now it's a matter of substituting into the formula of Tn here. Remember, we said our Tn is equivalent to an squared, and our a is -1, so it's -n squared plus bn, which is plus 36n, plus c, our c, which is 51. So that's your Tn, guys, in terms of n. So as you can see, it was pretty clear and straightforward question. All you need is to be very, 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 very careful, very, very careful on working out these questions. All right, 2.13, which term or which terms? So it's actually, it can be a term or they can be terms of the pattern. Here's a value of 320. Take note of this pattern, the quadratic pattern. So they are saying Tn is equal to 326. Find the value of n. Find the value of values of n. That is what they are simply saying there. Okay, so we have our Tn here. So it's just a continuation because already Tn is there. This is your Tn on 2.12. So we've got 2.13. We are given that Tn is equal to 326. And that Tn is there. In terms of the quadratic here, we are given our Tn as -n squared plus 36n plus 51, then you just equate to 326. We have formulated a quadratic equation that you are supposed to solve now using any method. It can be quadratic formula, quadratic, I don't know. All right, but before that, there is a need for you to transpose. Remember, every quadratic equation, the format, just like what we had, ax squared plus bx plus c is equal to 0. So one side has to be equal to 0. So that's what you're going to have. So you're going to have -n squared plus 36n, then definitely transpose the 326 to the left-hand side. So it's going to be a -326. So it's 51 minus 326, 51 minus 326, which is -275. All right, so that's -275 is equal to 0. So just for for avoiding errors, this and that, just try to make sure that the coefficient of n squared is a positive here. So you can divide by -1 each and every term here so that it can be a positive if we divide by -1 each and every term like that. All right, so that will be n squared -36n plus 275, which is equal to 0. So it's now a quadratic, normal quadratic. Yes, you can apply your factorization, but look at 275. Most of you guys do. If these factors, it will be a big problem. So just use your quadratic formula. Yeah, no one is going to arrest you for using a quadratic formula, guys. Anyways, all right. So as for me, if I've got values which are big like this, I just opt for the quadratic formula, which says that any, which is now n, because there we're dealing with x. Now we are dealing with n. So n is equivalent to -b plus or minus the square root of b squared minus 4ac all over 2a. So this is what you're going to have. All right, so that means the n that we're supposed to find is -b. All right, here the coefficient of n squared is 1. So we are going to have our a as 1, our b as -36, our c. So here we're going to have negative, okay, which is -36, that's minus b, plus or minus the square root of b squared, which is -36 squared, minus 4 times a, which is 1 times c, which is 275, everything over 2 times a, which is 2 times 1. So that's you and your calculator now. To find the value of n, we can simply, okay, negative and negative, that's a positive 36 plus or minus the square root of, I just need the calculator to simplify this part under the square root, which is -36 in bracket squared minus 4 times 1 times 275, which is going to be 196, everything over 2 times 1, which is 2. So you can separate the plus or minus of the square root. So that's 36 plus the square root of the 196 over 2. All right, over 2, like that. So you're going to have 25. So n is going to be 25, or n is equal to, just have to substitute here, put a negative in place of a plus. So that's it, delete this and put a plus, which is 11. So the terms that we have, they are positive. So definitely our n can be 25 or it can be 11, because these terms, they're all positive. If we had a negative term, then we are going to remove the negative term, but here they are all positive. So that means we are going to have these answers as they are. There's nothing that we are going to do on our answers there. All right, so that was it. 2.13. All right, let's check the other part, which is on 2.14. We are given that 10 adds a constant k to each terms of the pattern. Take note, guys, this person had to add k to each of the terms in the pattern, giving a new term, a new pattern Pn. Determine the general term of the new pattern. The general term, just like this general term that we had here. Remember, we had a general term of Tn here, which we had these values that we had here. Now this person had to add k in each and every term. Here there's a k, here there's a k, here there's a k, here there's a k, like that. Okay. What actually happens, guys, is that whenever, take note what I'm saying here, whenever you add a constant, it only affects also the constant term, which is the c part of the Tn expression, an squared plus bn plus c. That's where that constant is going to, it will only affect the constant. So if you add a k, you are just going to add a k on your constant. That's it. So it means we had our Tn here. Where is our Tn? This is our Tn here. Our Tn was -n squared plus 36n plus 51. So we're going to take that Tn, but now you just have to add an n. So maybe I can even write it here so that I don't go further from this answer here. So this is 2.14. So your Tn, but now it's written as Pn. It's now a new statement. It's no longer Tn. So in place of the constant, that's where you're going to add a constant. So it's -n squared plus 36n plus 51 plus k, like that. That is the new expression. Even if the constant, it's a number, let's say they said you added 3 or you added 5 or you added 10. you just add that 10 on the constant term. That is what this question is all about. Yes, you can go back to the normal expression. What you're going to see that, let me show you here. What you're going to see here is that if you are to add k in each and every term here, the only part that is going to change is this part. That is the only part that is going to change. All these k and k, they will cancel, which means the rest will remain as it is. The value of a will be the same. The value of b will be the same. But when you are calculating the value of c, that's where now you are now having a plus k. So you'll be having something like this. I wanted to show you something here. Your c is the only one that is going to change. So remember how you got your c here. This is this way that we got our c. It was a plus b plus c is equal to 86. But now it is going to be like this. Let me show you what it came from. A plus b plus c is equal to 86 plus k. Remember, your a was negative. We got -1 plus 36, which got us here. This is not going to change. So we've got 35 here. So we still have our 35 here. From these two, we got 35 plus c is equal to 86 plus k. So as you can see, 35 to this side is going to be c is equal to 86 minus 35 plus k, which is the same way that we got here, which is going to be 51 plus k. So that is the only part that is going to affect the c. The a is going to remain as it is because it is from the second difference and this one does not change. So a is going to remain as it is, b is going to remain as it is. So in short, just add the constant on your final answer, just like what we had here. So that was our 2.14 whenever you add a constant. So this type of equation, be very, very careful because they ask this typical, they actually ask this typical question. As you can see, it was actually just 2 marks for that. All right, anyways, let's check 2.2. The first 3 terms of an arithmetic sequence. This is now an arithmetic sequence. All right, these are the terms of the arithmetic sequence. Determine T30 on 2.21. Determine T30. That is, we are given that the number of terms there are 30 there in terms of y. Take note, your answer must be in terms of y. Okay, what are we going to do? Let us just have our terms down. Okay, even we can just even write it here. All right, so this is our T1, all right, our T1, our T2, our T3. So as we know that T30 from Tn is equivalent to A plus N minus 1 by D. This is a linear sequence or an arithmetic sequence where we need the first term being A, and that's our A here being the first term. D, that is the one that you're going to need, and D is going to be T2 minus T1, or it can be taken from T3 minus T2, whatever that you're going to use. Okay, so taking T2, which is 4y minus 1, then we subtract T1. So I'm going to put brackets on that part that I'm subtracting so that the negative affects each and every term. So it's 4y minus 1, negative times 2y, that's negative 2y, negative times negative, which is positive 1. So you're going to have 4 minus 2 by collecting like terms. That's 4 minus 2, which is 2y, negative 1 plus 1, that's a 0. So which means the D is equivalent to 2y. And the number of terms we are given here, T30, which means we're referring to any being equal to 30. So T30 is equivalent to A. Let's substitute our A, the first term, which is 2y minus 1. So it's, remember, in terms of y. So it's 2y minus 1 plus any minus 1, that's 30. So it's going to be 30 minus 1 times D, which is 2y. All right, so that's it. We can simplify. Yes, guys, just simplify. You can't just leave your answer like that. All right, so simplify further. What are you going to have here? So T30 is equivalent to 2y minus 1 plus, this is 30 minus 1, which is 29. So 29 times 2, that's something like 58 there. So we are going to have 58y. Okay, so we've got 58y, or you can just use your calculator to cross-check. 29 times 2. All right, that's 58. So collect like terms, we've got 2y here and 58. So 2 plus 58, that's 60. So it's going to be 60y minus 1. So this is our T30 in terms of y. So that's it. We are done. All right, that's it, guys. We are done. All right, 2.22 to mark the last question. You're having 4 marks. And They are now saying determine the value of y given that the sum of the first 30 terms is in this sequence is actually negative 2,820. All right. Remember, for the sum of terms, there are so many ways that you can actually use. I'm just gonna utilize this space here. Sum of terms can be given because remember, they are for the first 30 terms. So if they are for the first 30 terms, here we've got our T30 here. So this is our last term. And we have the first term, definitely. Our first term is there into the sequence. We've got our A. So you can use the shorter way or the shorter formula of Sn being equivalent to n over 2 into A plus L because it's for the 30 terms. All right. So the sum of the first 30 terms is equivalent to negative 2,820. So Sn is negative 2,820 equal to n over 2. Our n is the 30 terms that we are talking about. So that's our n. So it's 30 over 2 into A plus L. A being the first term now. So the first term is written in terms of y here, which is 2y minus 1. So you're going to take that first term as it is. That's 2y minus 1. All right, and the last term is the 30th term because we're talking about 30th term. And the 30th term, we calculated it before, we got 60y minus 1. So it's going to be plus 60y minus 1. Since I'm adding, there's no need for opening brackets. Opening brackets are important whenever you're subtracting, not when you're adding. When you're adding, it's not a big deal. But remember, this is not the only formula for sum of terms. Remember, we can use our sum of terms from the formula of Sn is equivalent to n over 2 into 2a plus n minus 1 by d. Yeah, we can use this formula here. Yeah. But if you can see a lot of things, here's just a repetition from what we had. So yeah, but you can just use this formula. All right. So let's work with this one that I've already cited here. We've got negative 2,820 is equal to 30 divided by 2. That's definitely a 15, which is equal to, expand the bracket, 2 plus 60. That's 62y. Then we've got negative 1, that's a negative 2. Negative 1. You can even use your calculator, that's a negative 2. All right, so it depends with how you're going to expand. To solve, someone can expand the brackets, or you can just divide by 15. Why do you need to work with bigger values? Just divide so that you work with smaller values. So there we are going to divide negative 2,820 divided by 15. We get a smaller value like minus 188. All right. So negative 188 is equal to, we no longer have the 15 here. We are just left with a 62y minus 2. So you can just solve, as you can see, transpose the negative 2 to that side. That's a plus 2. So negative 188 plus 2 is going to be negative 186. So we've got negative 186 being equal to 62y. So to find the value of y, definitely there is a need for you to divide both sides by 62, both sides by 62. So y is going to be, sorry guys, all right, I was on the PDF, not on this one. All right, so that's negative 86 divided by 62, which is negative 3. All right, so that's the value of y there. So the question was for you to calculate the value of y, not to give us the number pattern after that, right? No. Answer the question. Most of you guys, you do not answer the question. You try to attempt your own question, which is not it. That's not it. Attempt the question the way that you asked. So that was actually number patterns. We worked with the quadratic number pattern, arithmetic sequence there. So we are going to focus on March, working with the geometric, with all of them. So tune in still at Mason African Motives, and don't forget to like, subscribe if you are new. Also to share our platform to your friends and colleagues so that they also can benefit from this information. If you're at school, yeah, share with your colleagues at school so that they can also benefit from our channel. And let's revise as much as you can, working with question papers and revision. That can actually help us. And if there is any topic or any part that we still have challenges, let me know so that we can work on those areas while we have time. That's it, guys, for Mason African Motives. Till we meet again.